Hey guys, Mr. Wood back here with our next lesson for chemistry. Hopefully you guys are following along. I do have jokes for you today. Always have jokes, so here we go. Why shouldn't you give someone a gate? Because they might take offense. Not bad. Riddle. What kind of ears do trains have? Engineers. Engineers. And the last one, what kind of teeth cost $1? Buck teeth. Okay, so that's the highlight of the lesson. Okay, today what I want to do is I want to continue in chapter 2. We're learning about something called significant figures, and it's really all part of science, measurement science. It's kind of painful, but it's the rules. It's the rules on how it works when we make a measurement and we do a calculation. So I'm going to kind of change a little bit what is in my notes, and I'll explain that. So here we go. So I'm in the notes for chapter 2. So let me get this up. I'll show you what I'm going to change. Okay, so here we are. Okay, so here are the notes for today. Okay, and I'll scroll down. But significant figures, this is going to be important when we do measurements and also when we do calculations. So the first of all is in measurement, and this is part of the reason when we did the Alka-Seltzer lab, I wanted you to measure temperatures to the 10th. So when in a measurement, just like it says here, you want to record all the digits you are certain of plus one uncertain number. The last digit recorded from a measurement is estimated. And the way, like what it says in the example, is the way that I always do it, is that whatever the measuring tool goes to, you go one more place. You go one more place. And I'll do some examples here on the board. I'll do some from the worksheet too. So, and this will be for us when we do temperature, when we do volume, we measure length, that it will all factor in. The balances are digital and time is digital, so it probably won't be quite the same. So a measurement, whatever the measuring tool goes to, you go one more place. The last number is an estimated number. Okay, in calculation, the key, so that's the rule in measurement. Now in calculation, I'm going to change this and I'm going to go to the handout. So I'm going to ignore this dot right, not left method. So let me, okay, so let me on the board. First of all, back to measurement. So in measurement, I always use, because I'm a sports guy like you guys already know, and so football there's, so this is in measurement. So a football field is like this, and they do hashes. So they got the 10-yard line, and then they got the 20-yard line, and then here, and what they do is they have the hash marks like this. Well, what I said in a measurement, whatever the measuring tool goes to, you go one more place. So if the football was right here, so technically by sig figs, the measuring tool, the football field, goes to the 1, so we would go to the 10th. So we would say this is 17.7, which means this is an estimated number. We'll do some examples like this. Okay, different than in what I have in the notes, I want to just go from here because the rules really write what's in here, because what's confusing are zeros. So the rules on counting sig figs. So all numbers 1 through 9 are significant. All 1 through 9 numbers are always significant. So if I had, say I have 418, that would have 3 SF, 3 sig figs. All those would be significant. The key are the zeros. The zeros are what are the keys. So the rule on zeros, and this again comes right off the handout. First of all, leading zeros. Leading zeros are never significant. Now they're part of the number, but they're not part of the counted as sig figs. So if I have this number, 0.00042, those zeros, they are part of the number, but they are not considered significant figures. They just determine the decimal place. So this would have 2 significant figures. Like this has 1, 2, 3. This would have 1, 2. So leading zeros are never significant. Two captive zeros are significant, are always significant. They're always significant. So if I have this number, say I have 102.03, those are what I'm calling captive zeros. And so zeros that fall between non-zero numbers, those are always considered significant. So 1, 2, 3, 4, 5. So this has 5 significant figures. We'll see SF a lot over the course of our class, and that's what those are. Okay, so leading zeros, never significant. Captive zeros, always significant. And then trailing zeros, this is zeros, are only significant when there's a decimal place. So they're only significant when there is a decimal place. So this is as kind of strange as this sounds. If I have 200 without a decimal place, these are trailing zeros, so they would not, those zeros would not be considered significant. So this would have 1 significant figure. But if I have 200 with a decimal, it's of course the same number, but in terms of significant figures, it would have 3 significant figures, okay? So we're going to do a bunch of practice here in a minute, but non-zero numbers are always significant. Zeros, leading zeros, never significant. Captive zeros, always significant. And trailing zeros are only significant when there is a decimal place. Okay, now back to the notes. Again, we're going to work on this handout here and make hopefully make some progress. And when you come to class on Monday or Tuesday, you will surely have some questions. Okay, so now the rule about multiplication and division. And so all this, so we talked about measurement. Whatever the measuring tool goes to, you go one more place. And now in calculation, first counting significant figures. And the rule for multiplication and division is the answer, how you round. Really, it's about how you round. The answer that has the smallest or the same number of figures as the measurement with the smallest significant figures. So your answer will have the fewest sig figs. All that being said, if you multiply or divide a number that's got 4 sig figs and another number that has 2 sig figs, your answer has to be to 2 sig figs. You can't add sig figs. And that's what we're going to do 95 to 97% of the time is multiply and divide. So our answer will have the same number of sig figs as whichever number had the fewest sig figs. So we round to the fewest sig figs. Now addition and subtraction, as confusing this is a different rule. The rule here is we will round to the lowest decimal places. And we're not going to do a ton of addition and subtraction. But if we're adding one number that goes to the 10th and another number that goes to the 100th, then we would have to round to the 100th. Whatever number has the lowest decimal places is how you round. Okay, so I'm going to go over here to the overhead, and hopefully I'm going to get better at this as we go. Okay, so I'm going to the overhead. And so the worksheet I'm going to be working on is this worksheet here, back here. Now, this is going to be due in the next class. So I'm going to work a chunk of these to kind of get you guys going here. So I'm hoping I'm going to do better at this time than I did last time. Okay, so here we go. So I'm on this worksheet. Okay, and I kind of keep going back and forth. I want to make sure I'm speaking loud enough so that you guys can see this. So the very first problem is about counting significant figures. So it says, tell me how many significant figures. So for number 1, captive zeros, so the answer there would be 4. For 2, trailing zeros, but because there is a visible decimal place, The answer there would be 5. So trailing zeros are significant when there is a visible decimal place. So that would be number 3, those are all significant, so that would have 3 significant figures. Number 4, same thing. Non-zero numbers are always significant. I'm hoping you guys can see that. Number 5 would be 2. That 0 would be significant because there is a decimal. 6 would be 3. 7 would be 3. And number 8 would be 4. Okay, so in doing that, I'm counting, the key are zeros. So when I come down here, 4.050, well, the captive 0 counts and the trailing 0 counts because there is a decimal, so 4 sig figs. Okay, so counting sig figs. Okay, the next thing now is measurement. So remember, whatever the measuring tool goes to, we go one more place. Okay, so if I look at this first reading, it falls right here. So the measuring tool, this is 2 and this is 3. Each of these is to the 10th, which means I then would want to go to the 100th. So I'm going to say 3.00. Now, one of you may have looked at that, or one of your friends, you go, no, say 2.99. Well, that would have been okay. The key thing is the last number is an estimated number. Okay, so if I come over here, again, same thing. So every line here is representing the 10th. So that would mean I would want to go to the 100. So I have 2.20. So again, if you had said 2.21, that would have been okay because you needed to go to one place past whatever the measuring tool goes to. Okay, so for then letter C, here in this case, every line goes to the ones. So we would want to go to the 10th. So what I have here is 4.4. Okay, which means to me the second 4 is an estimated number. It's a number that I'm not sure about. So the measuring tool here goes to the 1, so I go to the 10th. Okay, and I'll let you guys try number 2. So that's the rule on measurement. Okay, now in calculation. So when we multiply or divide, like the first 5, we round based off the number that has the fewest sig figs. So when you multiply or divide, again, how we round is based off the fewest sig figs. So for number 1, 5.22 has 3 sig figs, 82.7 has 3 sig figs. So that means I want 3 sig figs. So I'm going to round it to 1, and the 6 tells me to round up. So I'd have 432 meters squared. And even here, even though we're really focusing in on the numbers, I still want to remember the unit. It's rare in chemistry that we don't do a problem where we don't have a unit. Okay, number 2. So again, we're doing multiplication. So these zeros here are not significant. Whoops, I gotta move this down. Okay, so these zeros here are not significant. So that has 3 sig figs. This has 2. So that means I would want to round this to 2. So I'm going to round at the 0, and the 9 is going to have me round up. So it's going to be 0.21 centimeters squared. And again, this is what we're going to do like 95 to 98% of the time, is multiply and divide. Okay, the next one, 4.08 has 3 sig figs. These zeros are not significant. The leading zeros are not significant. So this has 2 sig figs. So this one would be 67. In this case, since we're doing division, it actually does not have a unit. Okay, on number 4, this has 4 sig figs. This has 4 sig figs. So this would actually be the correct answer there. 0.7863. So again, when I multiply or divide, my answer has the same number of sig figs, which is whichever number had the fewest sig figs. Okay, here, this number has 5 sig figs. This has 3. These zeros are significant because there's a decimal. So I'd want to round this to 3 sig figs. So I'm going to round at 7. The 8's going to make it round up, so it's 0.968 amps per cubic centimeter. 968. Okay, now the rule changes. So when we do addition and subtraction, it's not about counting significant figures. It is about the decimal place. So here, this goes 3 to the right of the decimal. It's to the thousandth. This goes to the hundredth. This goes to the tenth. So we have the least decimal places. So in this case, this would go to the tenth. So I'd say 346.9. 346.9. So when you add or subtract, it's a different rule in how you round. Okay, so here we're to the 10,000th, to the hundredth, to the thousandth, to the hundredth. So that means I'm going to round this to the hundredth. What I get here, when I do this on my calculator, I'll write it over here, I get 22.037. But because I want to go to the least decimal places, which is the hundredth, I'm going to go there. So I'm going to get 22.04. Okay, so that's going to be the answer for number 7. Okay, for number 8, again, a subtraction problem. Both of these go out to the thousandth, so that would actually be the right answer there. 15.236. And then down here on number 9, again, the least decimal places would be the hundredth, so I would have 3.50. And I'll let you guys try letter E, and we will go over that on Monday, Tuesday. Okay, and then finally, let me just do a couple on the back page. So on the back page here, so we go back to the same rule in terms of measurement. So whatever the measuring tool goes to, I go one more place. So in number 1, the measuring tool goes to the tenths. So I would want to go to the hundredth. So I'm going to say 4.7. And that last number is estimated. I'll say 2. You might have said 4.71. It would have been okay. The key is that you went to the hundredth. Let me move that back up. Okay, so then number 2. So in number 2, every line here represents same thing, the tenth. So I'd want to go to the hundredth. So I'd say 4.60, which means that that zero is an estimated number. Okay, let me do a couple more. So number 3, what I get, same scale. So I'm going to go 5.00. I want to go, the measuring tool is going to the tenth, so I would want to go to the hundredth. On number 4, the measuring tool is ones, 30, 40, so 31, 32, 33, so on. So if this is going to the ones, I would want to go to the tenth. So what I have here is 32.5. And again, that last number, the one I'll underline, this is always estimated, which means then that the way you read it and the way I read it might be a little bit different. Okay, number 5, the same scale as number 4. So what I had for number 5 is, again, every line goes to the 1, so I'd want to go to the 10th. So I'd have 30.2, meaning that is estimated. Okay, number 6, I'd have 32.0. Again, the same scale. I would go there. Okay, let's make sure you guys can see what I'm doing there. Okay, almost done. Okay, so number 7, what I got for number 7 is 30.0, which means I'm sure of the ones, I'm estimating the 10. Okay, number 8, if you look at number 8, okay, if you look at number 8, 600, 700, so these are 10, 610, 620, 630, which means I would want to go to the ones. So what I have here is 692. Okay, the last one, and then I'll stop. When you have a reading, I keep looking in here, making sure you guys can see what I'm doing. But like this is called a meniscus, and something we'll talk about later. You always want to read it on the bottom. Now, this measuring tool is the same thing. It's going to the tens. So I would want to go to the hundreds. So I have this as 605, which means the 5 is an estimated. The 5 is an estimated number. You guys see what I did there? I'm in the way. I'm probably a good, I guess it's over here. There we go, 605. Okay, last thing is make sure, and if you guys are doing this, you guys are going to come to class on Monday with questions, or Monday, Tuesday. So what is due, the next time I see you guys here, the lab will be due, guys, on Tuesday or on Wednesday, Thursday. But what's due is this is the reading, the worksheet. So we'll go over this some more. We'll practice it some more. These are the problems from the book, 34 through 54 even. Don't do 38. And we'll have another little quiz, but I will take your guys' questions first. So, hey, have a good weekend. Keep up the good work and keep working outside of class. Talk to you guys next week.